So guys, for your 4, 5, 4, 6 test review, you are going to have on your test, it's going to say amplitude and align, reflection align, phase shift align, vertical shift align, time period align. You have to answer all of those questions for each one. Those questions aren't going to be worth as much as actually you putting them on the graph and showing me that you understand how to do it. But you need to be able to identify what is going on from the beginning. If I start with my sine, do you guys see how this is a sine graph? I'm going to start where? X-axis. So I know that in my mind. First thing I'm going to identify is the amplitude. The amplitude is the number that's right in front of the function. So the highest and the lowest that this graph is going to go is what? 2 and negative 2. Good. Then I'm going to look at the time period. For our sine, cosine, and their reciprocal functions, how do I find the time period? It's 2 pi divided by the number that's right in front of x. So my time period is from 0 to pi. Everybody understand that? Okay. Is there a vertical shift? No. On your test, it will say, if there is not one, write the word none. So there's no vertical shift. There's nothing being added or subtracted to the end of this function. Is there a phase shift? Am I moving this left or right? No, because there's nothing in parentheses being added or subtracted to x. Is there a reflection? No. Where would a reflection occur? In front of the very beginning, before the 2. So you know this is just a normal sine curve. So I'm going to start here at 0, and I'm going to end at pi. Now I have to figure out my little tick marks in between, correct? So I'm going to take my whole time period and divide it by 4 pieces. So each little tick mark is worth pi over 4. So my first tick mark is at pi over 4. My second tick mark is at 2 pi over 4, which is pi over 2. Good. My third tick mark is at 3 pi over 4. And my last tick mark, you can always check, is at 4 pi over 4, which is just pi. Then I'm going to identify my amplitude. So the highest it goes is 2. The lowest it goes is negative 2. And where did you tell me my sine curve starts? X-axis. At the x-axis. So I go here, and I go which direction? Up. I go up because it's positive. Good. Back to the x-axis. Down here. Back to the x-axis. And you connect in a nice, smooth curve. Yes, sir. Okay, let's look at the second one. There's a lot going on in this, but you can identify all of the things, if you want to say it. First thing let's look at. Just read left to right. What does that negative sign mean? There's a reflection. What is it going to reflect over? Over x. Make sure you write that. Don't just tell me yes or no. Reflects over x. What is my amplitude?
4.
It is 4. Yes. Right here. This number right there. It's a sine curve. So where does it start? X-axis. Good. What is the time period? Okay, it's 2 pi. 2 pi divided by 1/2. So if I keep change flip, it's 2 pi times 2. So it's 4 pi is my time period. Right?
Oh, so then that's easy. You just do pi.
Yeah.
2 pi.
Is there a phase shift? Do I move left and right? No. Is there a vertical shift? Yes, there's a vertical shift. So on that line, you guys would tell me it goes where? Up 2. Tell me the direction. So Sean just said, oh, wait, this one's pretty easy because if my whole time period is from 0 to 4 pi, if I take 4 pi and I cut it into 4 pieces, it's how much? Just pi. So my first tick mark is 1 pi. My second tick mark is 2 pi. My third tick mark is 3 pi. And then what's my whole thing? 4 pi. And my amplitude is 4. Agreed? Now, this is a vertical shift. I suggest you graph your function, then do the shift. It's easier to do. I'm going to graph without the vertical shift right now. I'm going to say, okay, I start at the x-axis because it's a sine curve, correct? Yes? But it's negative, so I start at the x. Yes, sir?
Are you going to do the 2 lines in 2 separate colors? So that way
Yeah. I'm going to start at the x, and instead of going up, I'm going to go which way? Down, because it's negative. It's a reflection. So I go down to -4, and then at 2 pi I hit the axis, and then at 3 pi I'm at +4, and then at 4 pi I hit the axis again. So here is my sine curve. So you guys can visually see where those points are, what your curve looks like. Now what the correct answer is that whole curve, but moved where? Every point moved up 2. So this first point at 0, 0, I'm going to move it up 2. So this point at -4, I'm going to move it up 2. It's -2. You guys see that? So this one at 0, I'm going to move up here. This one at 4, I'm going to move up to 6. And this one at 0, I'm going to move back up to 2. So here is your answer. You do not have to erase your original. Just make sure that your first thing that you drew is dotted or something. So I know, hey, that's not the one to look at. Andrew.
Would you like draw that in general, the dotted one?
Say it again.
Would you need to draw that to show the shift, or do you have just draw it in for the
You can just, some people like to just show the graph already shifted. I personally would like, if I was doing it, I would do the original and then so I could see that I shifted it the right number of spaces each time.
But it won't be marked wrong if I did that.
Nope. Okay, you guys okay? All right. All right. Scoot. Okay. More going on in this one, but no big deal. No big deal at all. First thing I'm going to look at is where is this going to start? At the amplitude. Why is it starting at the amplitude? Because it's a what? Good. Okay, so what is my amplitude here? 3. Good. What's the time period? It's 2 pi divided by what? Divided by 4. Good. So my time period I'm talking about is just pi over 2. That's it. Just from 0 to pi over 2. Is there a phase shift? There is a phase shift. All right, this is where it gets a little tricky, guys. Which way is this going? So I'm going to say there's a phase shift of right pi, which means I'm going to do what to every single one of my little intervals? I'm going to add pi to it. If we're going to the right, we're adding, right? Is there a vertical shift up or down? No. Is there a reflection? No. Is there... We already answered phase shift. Okay, we're good. Okay, so now there's a couple different ways you guys can do this. I need to see your correct graph. So if I were you, I would maybe go, okay, this is 0. What was our whole time period? Pi over 2, right? So I got to find my tick marks in between. So if I take pi over 2 and I divide it by 4 pieces, right? Agreed? So it's pi over 2 times 1/4. So each little piece is worth how much? Pi over 8. So my first tick mark is pi over 8. My second tick mark is 2 pi's over 8, which is what? 1 pi over 4. My third tick mark is 3 pi's over 8. And my last tick mark is 4 pi's over 8, which is the same as pi over 2. Okay, so here is my original. If I was just doing my cosine curve over the original time period of 0 to pi over 2. But I'm not. I'm taking that curve and I'm doing what to it? I'm adding pi. I'm shifting it to the right. So what do I have to do to every single one of those numbers? I have to add pi to it. So if I were you, this is what I would do. I would say, okay, let me write down what I have. I have 0 pi over 8, right? 3 pi over 8, and pi over 2. Oh, I skipped pi over 4. Sorry. Hang on. So I have pi over 8, pi over 4, 3 pi over 8, and then pi over 2, right? You guys understand where I got the numbers from? Now, what am I going to do to each one of those numbers? Not multiply. We're just moving it. Which way am I moving it? Right. So I'm adding pi or subtracting it? Adding. So I'm going to add pi. See what my answer is. I'm going to add pi. See what my answer is. Add pi. add pi, add pi. So when I say 0 plus pi, what is that? Pi. If I change this to eighths, I have 1 pi plus 8 pi is 1 plus 8. 9 pi over 8, good. Then I have pi over 4. If I change this to fourths, I have 4 pi over 4s plus 1 of them gives me how many? 4 plus 1. 5 pi over 4. All right, I got to change this one to eighths. So I have 3 plus 8 is 11 pi over 8. It is.
No.
And then 1 pi over 2 plus 1 pi over 2.
Wait.
Sorry. My bad. 1 pi over 2 plus 2 pi's over 2 gives me
3 pi over 2.
Okay, so do you guys see where we got all those numbers from?
Yeah.
All right, I know it seems a little jumbled and that sort of thing, but all you're doing is now just you're making sure that your shift is shown in your little intervals. So what I'm going to do now is I'm going to erase these. I don't want to see these tomorrow.
See what?
I don't want to see the originals. I want to see your shift. So my new asymptotes, my new time intervals, my pieces. My first tick mark is at pi. Agreed? What's the second one at?
Wait, just for that one?
9 pi over 8. Then my next tick mark is at 5 pi over 4. Then my next tick mark is 11 pi over 8. And the last tick mark, because we're shifting the whole thing over, I need to see the whole time period, is 3 pi over 2. So my amplitude is 3. It's a cosine. Cosine starts where? At the amplitude. So I'm going to start at positive 3, but not at 0, because we shifted our graph where?
Right.
To the right. So I go here, x-axis, negative x-axis, and back up. So when you draw your curve, you guys can show me that your intervals are correct and you don't start at 0 because you moved over the amount of pi. All right, let's go to the next one. This one's different. How's this one different? Cotangent. Cotangent and tangent are different, guys. How are they different? They have asymptotes. So the graph looks completely different. So the first thing you're going to do is let's run through the stuff that we know. There is a reflection here, right? You need to make sure that you see that. The only two things I'm going to ask you for a cotangent and tangent are, is there a phase shift, and what are the asymptotes? And then you have to graph everything. So in this case, is there a phase shift?
No.
Yes.
Yeah.
Where does this graph move? Left, how much? Left, pi. So what are you going to do? Once you find your two asymptotes, what are you going to do to those two asymptotes? If I'm going to the left, you're going to subtract pi. Okay, now pay attention. All right, so how do I figure out the asymptotes for cotangent?
What'd you do?
0 and pi. So whatever is with it, I said x equals, just x. So x equals 0 and x equals pi. Okay, that's super easy. But those aren't actually the ones that I'm going to use. What do I have to do to find the ones I'm going to use? How do I do that mathematically? I'm going to subtract pi from both of these. So my two asymptotes that I'm going to build everything else off of is at negative pi, and where else? And at 0. So I have negative pi, and I'm at 0. Agreed? Now, when we have cotangent, how many asymptotes do I need? Cotangent.
3 snakes and 4 legs.
Cotangent. It's 5 and 4.
It's 5 and 4.
So, how far is it between negative pi and 0? What's the distance? Pi. So I know that I'm going to have an asymptote here at positive pi, correct?
Yeah.
Where else am I going to have asymptotes?
2 pi.
At 2 pi, and where else?
3 pi. Or negative 2 pi.
Negative 2 pi.
Could you go with 3?
You could go to 3 pi. Could you go to negative 3 pi?
Yeah.
Absolutely. So I'm going to draw my asymptotes. So you will be asked to tell me what the asymptotes are. You'll have to tell me all 4 or 5, however many you do. And then I need to see the graph. This is a cotangent. How does cotangent generally go? Increasing or decreasing? Decreasing. But this one is increasing because there's a
Negative.
reflection. So you would go here. And like I said, guys, I'm not concerned 100% with where you hit the x-axis. I just need to see that you are in between your asymptotes. You don't touch them. Correct? If you draw your graph and it touches the asymptotes, I'm taking points off. That's just being careless. I need squiggles. All right, let's look at the next one. Tangent. I need, is there a phase shift?
Yes.
There is a phase shift. What is it? The phase shift is left pi over 2. How do I find asymptotes for tangent?
It's 0 and no.
Oh, it's negative pi and pi, right?
It's not negative pi. It's not 0. Tangent, guys.
I forgot.
For tangent, okay, well, it's really important that you remember that for tomorrow
Yeah.
is going to be negative pi over 2 and positive pi over 2. What? Okay, close is wrong, though, so the whole problem would be wrong. Guys, it's whatever is with the x. Since it's just one x, then there's your 2 asymptotes. But before I go and put those on the graph, I have to shift them. Which way? Left. If I shift something left, am I adding or subtracting? So I'm going to subtract pi over 2 from both of these. And when I do, where do I get asymptotes at?
0 and then, it's called negative pi.
Negative
2 pi. Negative 2 pi.
Yeah.
If I have negative pi and negative pi, that's negative what?
2.
That's negative 2 pi. Correct? Over 2?
Yeah.
So it really is what?
Negative pi.
Okay. And where's the other one? What's pi over 2 minus pi over 2? 0. So my asymptotes are here and here. How far is it in between negative pi and 0? It's pi. So I have another asymptote over here at negative 2 pi, correct? Where else do I have one? At positive pi. For tangent, how many snakes do I need? How many asymptotes?
3, 4.
3 what?
3 asymptotes. I mean, 2 snakes, 4 asymptotes.
No, 4 asymptotes, 2 snakes.
That's what I said.
That's what I said.
I said 3.
All right, tangent. Tangent is increasing or decreasing?
That's so wrong.
Tangent is increasing or decreasing? Increasing. So there's your snakes. Guys, out of the 5 questions on your test, 2 of them will be tangent and cotangent. How much is each question worth? 20 points. So if you're sitting here fooling around and everything's funny and you get 40 points off, the highest grade you can get is a 60. Okay, so guys, here's some reciprocal functions, all right? These are not crazy hard. You just have to remember. You're not graphing the function, you're graphing the reciprocal, the flip. So first thing I would do when I see a reciprocal is I would say, okay, cosecant. What is the cosecant reciprocal? Sine. All right, I'm going to think of sine. So when I think of sine, I think sine starts where? On the x-axis, okay? That's important for you guys to remember. So now you have to answer all the questions. What's the amplitude? 3. Good. That means the highest my graph is going to get is? The lowest it's going to get is? Good. If I'm looking for the time period, ladies and gents, time period, how do you find the time period? 2 pi, good, divided by Why are you saying 1/4? I agree. Don't look at me like, oh no, I agree. But why is it, why, where did you guys get the 1/4? There's a 1 in front of that x that you guys don't see. So if I divide by 1/4, I'm really doing what? Multiplying by 4. So my time period is 8 pi. Good. Okay, that's my time period of 8 pi. Is there a reflection? No. Is there a vertical shift? No. Is there a phase shift, left and right? No. So now all I have to do is just graph. So I'm here, it's 8 pi. So each little tick mark is worth how much? 2 pi's. So the first one is 2 pi. The second one is 4 pi. The third one is 6 pi. Good. My amplitude we said was 3. So positive 3, negative 3. Now, I am not graphing a sine curve. I am graphing the cosecant. But what I'm originally going to do is graph the sine so I can see. So I start where? I start at the x-axis, and it's positive, so I'm going which way? So I'm going to go up here, down here, down here, up here. And I'm going to dot that line because that's not the one that I'm looking for. That is not what I'm looking for. I'm looking for the reciprocal, which is just everything that's there, but what? How do I figure out what to draw? Where the graph crosses where? Sean.
The x-axis.
So I'm going to draw right here so I can see. Do you see how I hit every point where the x-axis, where it touches the x-axis? So in this first section, I don't want that black dotted line. I want the reciprocal. I want the flip part. So I would draw something that looked like this. In this section here, I don't want that black dotted curve. I want the flipped over version. So it looks like this. So tomorrow, if you give me an answer that looks like this, that is perfectly fine. But if you graph both of them as solid lines, I'm not going to guess which one you want me to look at. Yes, sir. You guys can keep them as long as they are dotted.
Wait, I'm talking about
The asymptote kind of thingies? Yeah, that's fine.
Yeah, you only need those two.
The two blue lines are the priorities.
The two blue curves are the priorities, correct. Is there a phase shift? No. Is there a reflection? No. Is there a vertical shift? No. You have to answer those questions. All right? Okay, good deal. Let's do this last one and then we're done. I think the ones that are going to give you the hardest trouble are the tangent ones and cotangent. But I see secant. So immediately when I see secant, I think what?
cosine.
Cosine. And I think cosine starts where?
And amplitude.
Good. So let's answer these questions. What is the amplitude? 2. Is there a reflection? No. What's the time period? How'd you figure that out? Correct. Number in front of x is 1, so 2 pi divided by 1 is 2 pi. Good. Is there a vertical shift? Nope. You would put none. Is there a phase shift? Yes. Where do we go? Left. Pi over 2. In mathematical terms, left means subtract or add. Subtract. So look, originally I'd have 0, and then pi over 2, pi, 3 pi over 2, correct? But I know those are not my tick marks. Those are not my intervals because we're doing what to the graph? Shifting it which way? Left. So what I'm going to do right here, I'm going to say 0 minus pi over 2. Then I have pi over 2 minus pi over 2. Pi minus pi over 2. 3 pi over 2 minus pi over 2. And 2 pi minus pi over 2. You guys agree with me why I chose those numbers? Okay, those are my originals. Now I'm just going to do a little simple math. What is 0 minus pi over 2? Negative pi over 2. Good. What's pi over 2 minus pi over 2? 0. Good. If I change this to seconds, I have 2 pi minus 1 pi gives me pi over 2. Good. 3 pi over 2 minus pi over 2? 2 pi over 2, which is? Pi. Great. And then if I change this, right? 3 pi over 2. So I'm going to, look, I'll just redraw it right here. I'm still at 0 here, but my first tick mark is going to be at negative pi over 2. Then I have 1 at 0. Then I'm at pi over 2. Then I'm at pi. Then I'm at 3 pi over 2. Agreed? What was our amplitude? 2. What is this curve that we're going to draw? Cosine. So I'm going to start where? At the amplitude, okay. And I'm going to come down here, and then here, and then here, and then here, right? Is this the curve that I'm answering though? No. I'm just going to draw this so that I can then draw the real one, or the reciprocal, we'll call it. And then I draw my boundary lines wherever x hits. So if I have this first one, instead of like a little curved thing going down, I'm going to do a curved thing going up. Just a flip. In the middle here, I don't want those black, I don't want the black part, I want the flipped over part. So I'm going to draw it downwards like this. And then over here, just something like that. Yes, sir?
Do the twos touch, like the points there?
Do the what?
Like the point, like the edge here, on those two curves. Do they
The
touch?
ones on the top?
Yeah, like
No.
like the one in the middle there. Should they touch or no? No, 2 points.
Which 2 points?
Like
What-
the two,
Okay, so that's it, guys. I will post this video. I also will post the pretty worked out review so you guys can look back at that. You have a homework assignment that's due tomorrow morning. It's 3 questions on tangent and cotangent because those are the ones that give us the hardest time. So it's just some extra practice that I want you to do and turn it in. All right, sound good?
Yeah.
Okay, thanks. Thank you.